This presentation is about hypothesis testing. We will define hypothesis testing and demonstrate how to set up the hypotheses for a hypothesis test. At the end of the lesson, you should be able to relate why we use hypothesis tests, identify a null hypothesis and an alternate hypothesis, and realize why the alternate hypothesis is sometimes called the research hypothesis. This is the formal definition of hypothesis testing: a procedure based on sample evidence and probability theory to determine whether the hypothesis is a reasonable statement. In simple terms, we wish to determine whether a statement made about a population parameter is likely true by using information gathered from a random sample of the population. Let's look at a simple example. Here's a statement about a population. The average age of the full-time students at College of Western Idaho is more than 25 years. The population is the full-time students at College of Western Idaho. The population parameter is the mean age of all of the full-time students at the College of Western Idaho. The statement is that the mean is more than 25 years. We could confirm or refute the statement by gathering the ages of all of the full-time students at the College of Western Idaho and calculate the mean. We would then compare our result with 25 and see if the true mean is greater than 25. If the mean is greater than 25, the statement is true. If the mean is less than 25, the statement is false. That would be the end of the problem. But in some situations, it may be very difficult or very expensive or even impossible to gather the data on the entire population. That is probably not the case in this example. But think of a parameter of the entire population of the country, or the entire production run of a product to determine defects, but the test to find defects is destructive, ruins the product. Can we determine if the statement is likely true by using only a random sample of the population? That's what hypothesis testing allows us to do. Finding random samples is usually easy, and the results can be very accurate. In this example, we could just take the ages of a class and assume it is a random sample. So, do we believe the average age is greater than 25? Or do we really think that it is less than 25? What would we like to prove? We have opposite strategies depending on what we want to demonstrate. If I really wanted to prove that hypothesis is wrong, I want to have evidence that the true mean is less than 25. If I want to confirm the hypothesis, I want to have evidence the true mean is greater than 25. The true mean is one or the other. Technically, it could be exactly 25, but that's very unlikely. Whichever way I set up the problem, the numbers will be the same. And I will either reject the null hypothesis or not based on the numbers. But the conclusion will be significantly different depending on how I originally set up the null hypothesis and the alternate hypothesis. Suppose I want to prove the hypothesis is wrong. Maybe a vice president of the school made this statement, and I think they're off, and I would like to prove that. The hypothesis I want to prove is the research hypothesis. The research hypothesis should always be the alternate hypothesis. Our alternate hypothesis will be the true mean of the population is less than 25. That leaves the null hypothesis to be that the true mean is greater than or equal to 25. It's easier to determine the alternate hypothesis first, based on what you want to prove. Then make the null hypothesis the opposite of that. Traditionally, the null hypothesis always contains the sign with the equals as part of the sign. The null hypothesis will be equal to, or greater than or equal to, or less than or equal to. The alternate hypothesis will always be either greater than, less than, or not equal to. Our hypotheses will be null hypothesis. The true mean is greater than or equal to 25. Alternate hypothesis. The true mean is less than 25. The alternate hypothesis is what we want to have evidence to support. There are only two possible conclusions to draw from this hypothesis test. One would be that we reject the null hypothesis. If we reject the null hypothesis, we have evidence that the null hypothesis is false, and the evidence supports our belief that the true mean is less than 25. This is a strong statement. The other conclusion would be that we cannot reject the null hypothesis. If we cannot reject the null hypothesis, we accept that it is true. We really don't have proof that it is true, but we don't have evidence that it is false. This is like the presumption of innocence in a legal environment. If the prosecutor cannot prove you are guilty, then you would be acquitted. You are not proven innocent. This is a weak statement. We accept the null hypothesis because we can't prove it false. Remember that we wanted to show the vice president wrong. So we set the alternate hypothesis to be that the mean is less than 25. However, if we want to support the vice president's position and confirm the mean is greater than 25, what will we do? To confirm that the mean is greater than 25, we would have a different null and alternate hypothesis. We would want to prove that the mean is greater than 25, so that would be our alternate hypothesis. And the null hypothesis would be that the mean is less than or equal to 25. Remember that the null hypothesis always has the equals part in the sign, equal to, greater than or equal to, or less than or equal to. And the alternate hypothesis always is equals, greater than, or less than. The first way we set up the problem would give us a weak conclusion if we found the mean to be greater than 25. So we switched the signs. Now our results will be either reject the null hypothesis and have evidence this vice president's statement is true, or do not reject the null hypothesis and accept that we do not have evidence the vice president's statement is true. This is the opposite of the results of the first situation. It is important to realize that the numbers will be the same in both situations, and the process is almost the same. The first case would be a lower tail test, and the second case would be upper tailed. The way you set up the problem makes a big difference whether your conclusion is weak or strong. So, in summary, a hypothesis is a statement that will be determined to either be true or false. Identify what you want to demonstrate and use that as the alternative hypothesis, which is sometimes called the research hypothesis. Then use the opposite of that for the null hypothesis. When hypothesis testing is completed, you may have evidence to support the statement you want to demonstrate to be true, rather than a weak result, I can't prove it wrong.